ናችሁ በባለፈው ቪዲዮ በደንብ derivative and summarize እንዳደረጋችሁ ተስፋ አደርጋለሁ. In this video I'm going to revise what we have discussed last time, and I'm going to go through the second part of the derivatives up to after the product rule. So from the previous discussion, we have if a certain function f of x is a certain constant, then it is derivative is, let me write it, derivative in short form is a constant, then f derivative of x is going to be 0. If you have a certain linear expression as f of x, which is ax, so then the f derivative for this one is going to be simply a. So in the case where you have f of x is equal to a polynomial expression ax to the power of n, so what you do is to get f derivative is just to multiply a, the coefficient, by that exponent, a times n, then to reduce the exponent by 1. For example, if you have f of x is equal to 6x raised to 4, so what is a? This a, the coefficient a is like 6. Then what is f derivative of x? Then what you do is 6 times 4, because so you have said that a x to the power of n turns to a times n x to the power of n minus 1. So this 4a is going to be, and then x is going to be how much? Reduced by 1, then 4 minus 1. So this is going to be 24. X raised to 4 minus 1 is 3. So this is the derivative of a polynomial. And the other important derivative that you should note on your book, on your note, is that if f of x is sine of x, then f derivative of x is how much? It is cos x. This is very important to note. Then if you have f of x is equal to cos x, then what is f derivative? Then f derivative of x is equal to negative sine x. That's one important thing. And the other thing to note is if you have f of x is equal to 1 over x, so the derivative of this one is very important. I'm gonna write it in another color because it's very important. So this, if f of x is this one, then f derivative of x is how much? Ln x, the natural logarithm of x. So this is very important to note, to remember, because you are going to use it now and again. And the other thing is, if you have f of x is equal to e to the power of x, then f derivative of x is the same. It is the e to the power of x. The derivative and the function are the same for f of x is equal to e to the power of x. But how do we do the, if you have f of x is equal to the exponential form, a constant to the power of x? So the form of exponential function like this one, then f derivative of x is very simple. You have a to the power of x itself and you multiply it by ln of a. Something analogous to there is kind of analogous between exponential and logarithm. So if you have f of x is equal to ln of x, all right, so we have already said that, which is the same as logarithm of x to the base e. You know what it is, what e is. So what is f derivative? This is again very important. It is 1 over x. So the logarithm of, the logarithm of ln x is 1 over x. So this is the other thing that you have to, so you can use the logarithm property to change the base this one. So this is the same as logarithm of x to the base e over logarithm of a to the base e, the base change formula. But logarithm of x to the base e is called ln x. So f of x is in the other way. It is ln x over ln a. This is what, this is ln, how you write the function itself as a ln in form of ln. So what is f derivative of x? You know this ln a is constant, 1 over ln a, all right, times what is the derivative of ln x? The derivative of ln x is the derivative of this one. Your ln x derivative 1 over x now. So f derivative of x is equal to how much? 1 over ln a times 1 over x. So simply, if f of x is what, if f of x is logarithm of logarithm of x to the base a, then its derivative, okay, the derivative of this one, which is f derivative of x, gonna be 1 over ln of the base times 1 over x itself. So this is equal to 1 over x ln x is the derivative. In today's video, we are going to talk about the how to derivate. Remember, another thing I forgot is, if you have f plus g, so if you are required to find the d per dx of what, f plus g, what you can do is you can take the derivative of each one, d per dx of f of x, or simply f plus or minus, it may be minus, then it is d per dx of what, g of x, or g, or you can call it. So this is the sum and the sum and the difference. I can give you example for this. For example, if f of x is equal to sine x plus 2x raised to 4. So how do you get the derivative of this? Then f derivative of x is equal to how much? Is equal to the derivative of d per dx of sine x plus d per dx of the polynomial one, 2x raised to 4, maybe minus. But what is the derivative of sine x? Then this is the same as cos x is the derivative of sine x, and plus the derivative of 2x raised to 4 is 2 times 4 times x raised to 4 minus 1. So this is the same as cos x plus 8x raised to 3. That's how you do. So now we have another example. If you are given a function f of x is equal to the power of x minus log x, so you can do this, the derivative of this function f of x derivative, you can take d per dx of e to the power of x minus d per dx of log x to the base 3. So it's very easy to get the derivative of exponential function like this. The only thing you do is just you multiply the original function by the ln of the base. So this is equal to the power of x times ln of the base ln 2 minus, how do you do this one, the logarithm. We have already discussed that above. You can first write ln of this is the same as ln of x over ln of 3. You can do like this. So this one is to the power of ln 2 times to the power of x minus, so you can take 1 over ln 3 common. Then what is the derivative of this one? The derivative of this one, so that is 1 over x. So what is the derivative of this one? If f of x is to the power of x minus logarithm of 3 to the base, logarithm of x to the base, x to the base 3, this is equal to ln 2 is a constant times to the power of x minus, so 1 over x ln x is a solution. So this is how you do this, a difference function. Sometimes you can split a function into some quotient functions, or you can also switch function into what, into some product function, or you can even if you can manage the function into some composite function. In this video, we are going to talk about how to do the derivatives of product functions, quotient functions, and the composite functions. All right, so if you have f times g derivative of x, very easy, yeah. So the derivative of this one is what? The derivative of this one is the first one, f derivative of x times g plus g derivative of x times the function f. Very easy, yes. Let's do this one example. If you have for example, you have a kind of function like what kind, 3x raised to 5, then is a power of x. How do you do this? 3 3x raised to 5 3x raised to 5 times e to the power of x. In the case where you have these things, you consider this if this is function f of x, so you consider this one as a product of two functions. You can call this one as h of x, and you can call this one as maybe L of x. Yeah, so that is the separations, and we are going to see that f of x, a given function, is a product of h of x and L of x, the product function. So what is the derivative of this product? H derivative of x times what? Times L of x plus L derivative of x times h of x is the derivative. Now let's find the derivative of h. So what is the derivative of this one? So, which is the derivative of h of x. So d per dx of h of x is how much? All right, so this is how much. This is equal to d per dx of 3x raised to 5. Now this exponential form, so this is equal to 3 times 5 times x to the power of 5 minus 1. So this is 15x raised to 4 is the derivative. And what is the derivative of e to the power of x? It is the only function. E to the power of x is the only function which is the same as its derivative. So e to the power of x is equal to e to the power of x. The derivative of it, the derivative and the function is the same. So this is a typical property of exponential function with base e. Now, so what do we have is now, so the derivative of 3x raised to 5 times e to the power of x is equal to the derivative of this one is how much? 15x to the power of 4 times e to the power of x minus, no, I'm sorry, plus the derivative of the e to the power of x is e to the power of x times the exponential, the polynomial one, x raised to 5. Okay, this is the derivative, but how do you simplify? You can simplify this as many ways. So you can write this one as 5 times 3, 15. You can write this one as x raised to 4 times e to the power of x. So plus, you can do this one e to the power of x times 3 times x raised to 4 times x, because x raised to 5 is x to the power of 4 times x. So when you take the common for these two terms, what is the common? So the last expression for x to the power of 5 times e to the power of x derivative, I'm sorry, there is a derivative here, so is equal to how much? It is you took 3 common, x raised to 4 common, e to the power of x common. So what is here? What you left with here? 5, then plus. So e to the power of x is taken, 3 is taken, x raised to 4 is taken out. What is here is x plus 5. That's the derivative. In the other case where you have f over g of x is given, if this is a given function, maybe you can call this is m of x, and they are going to split as a ratio of two functions. So what is the formula for f over g derivative of x? You do the numerator function f derivative of x times the g of x minus, take care, g derivative of x, the derivative of the denominator function, times the above function f of x over the square of g of x squared. Please note this one on your note and study this formula and the above formula, the product, for the product. This is for the what? This is for the quotient. Now let's do some examples on this one. Let's do this example. እስቲ ይህንን ምሳሌ እንስራው። ቪዲዮ ፓውዝ፣ ትራይት፣ ሞክሩት። እስቲ ሞክሩና ውጤታችሁ ቀጥሎ ከምንሰራው ጋር ታስተያያላችሁ። You can check later. So you separate this as two functions. So meaning m of x is in the form as h of x over h of x over maybe another function l of x, any function. So how do you do the derivative of this? The formula is you do h derivative times g minus l derivative times h over l square. That's it. So what is the derivative of this? You took this one is 4x to the power of 3. What's the derivative of this? It is 1. Yeah, the derivative of x is 1. And how do you apply it here? So the m derivative of x is equal to how much? H derivative times g. The numerator derivative is 4x cubed times g is what? X plus 1. Yeah, minus h derivative is how much? Oh, no, it's not. L derivative, I mean, it's 1 times the h of x is x raised to 4 minus 4 over x plus 1 g of the denominator function square, Ronald. So how much is this? All right, is there anything common? We can take it out. You can leave it like this. So this is 4x raised to 3 into x plus 1 minus 1 times that is x raised to 4 minus 1 minus 4. Okay, like this, over x plus 1 the whole square is the solution. You apply here the quotient. How do you do this one? If your m of x is tan x, okay, so what is m derivative of x? This looks like it's not a quotient function, but tan of x is defined as tan x is how much from your trigonometry over cos x. So this is a composite, I mean a quotient function. So to do this, now what we are going to do is tan of x is equal to sine x over, so the derivative of d per dx of tan x is how much? Sentinel d per dx of sine x over cos x is the solution. Now what is the formula for this? What is the formula for sine x over cos x derivatives? So if you have f over g derivative, you do f derivative g minus g derivative f over g squared. Yeah, so what is f derivative? What is the sine derivative? So let's do it like this. So the sine derivative, okay, so you have sine x over cos x. You are looking for the derivative of this. So this is equal to how much? The derivative of this is how much? Cos x, yeah, cos x times the denominator g of x. So cos x again minus, so what is the derivative of this one? Cos x. What's the derivative of cos x? Minus sine x. You have to take care for the sine. Times what? Times the numerator function sine x. Yeah, so over what? Over cos square x square, or like this. So this is the same as cos x times, so cos x times cos x is cos square x, and minus times minus is plus sine square x over what? Over cos square x. You know what? So from your this is a square, yes. So from your trigonometry, cos square x plus sine square x, how much it is? Unit, yeah. It's an identity. So the derivative of tan x is how much? The derivative of tan x is cos square x plus sine square over cos square x. So cos square x plus sine square x is 1. So 1 over cos square x. Yeah, but what is 1 over cos x? But this is sec x. Yeah, this is sec x. So the d per dx of tan x is equal to sec square x. Because you can write it this one. You can write it 1 over cos x times 1 over cos x. But this is, what is this? 1 over cos x is sec x. This is sec x times sec x. This is it. But this is sec square x. Sec square, the secant square of x. So d per dx of what? Tan x is equal to this much. How about tan cot x? What's d per dx of cot x? I'm sorry. What's cot x? Cot x. What is cotangent x? So this is equal to how much? D per dx of cot means the reciprocal of tangent. Cos x over sine x. Yeah, that's a quotient function again. So what is the d per dx of this? What is d per dx of this one? the cos x over. So it's a question. So you write, you are looking for d per dx of the derivative of cos x, yeah, cos x over sine x. So is equal to how much? The derivative of this one, the cos x derivative, don't forget this. All right, h over l is how much? H is a function, L is a function, so h derivative times L minus L derivative h over L square. That's pretty easy. So this is how much? This is d per dx of cos x over sine x is how much? So this is equal to the derivative of cos x is minus sine x, yeah? Minus sine x, yeah? So what is the L of x times sine x, yeah? Times sine x, yeah? So, okay, let me write this. So cos x over sine x derivative is, cos x derivative is minus sine x times sine x, the denominator, minus, what is the derivative of this one? No, yeah, this is because question we do minus. So what is the derivative of sine x? Cos x, yeah, cos x times the numerator function is cos x again, over sine square x, or sine x the whole square. Yeah, that is it. How much is this one? So you can take this minus, so minus sine square x minus cos square x. Oh, that's fun. Over sine square x, that's really fun. So when you take the minus common, minus 1 times, so you can take minus 1 here and sine square x here, sine square x plus cos square x. But sine square x over, so the whole thing over is sine square x. We know sine square x plus cos square x is 1. So minus 1 times 1 from your trigonometry over sine square x, yeah? You got it, sine square x. So what is, this is the same as, this is minus 1 times 1 over sine x times 1 over sine x is a solution. How much is this one? So times, this is times, so it is 1 over sine x is cosec x, yes? So minus 1 times this 1 over sine x is cosec x times cosec x, CSC x, yeah? CSC x, the inverse, the reciprocal of sine is cosecant. So what is d per dx of what? Cot x? Cot x. This is equal to minus sec square x. That's it. Because cos x times sec. Not sec. Not sec. What's wrong with me? Not sec. CSC square x. Cosecant square x. That's it. That's the derivative of cotangent. Now, how do we do composite functions? Okay, composite functions. Now, sometimes you need to take care whenever you are given a given expression. It needs a technique to split the given composite function into two functions. For example, if you are given f of x is equal to sine of x squared, yeah, sine of x squared is given. So what is the derivative of this one? Okay, before you do the derivative of this one, what you have to do is you split this one as a composite function. How? So I can say there are two functions, yeah? There are two functions. Their composition gives you f of x. So I can call the first one L of x. So L of x is how much? It is sine x. And the other one may be m of x, which is x squared. All right. I hope you can see this f of x, which is sine of x squared, is the same as what? The same of L of what? L of m, or L of m of x. So this is a composite function. So it's very important to split a given expression into a composite. But how do you do the composite one? So the composite function, FOG derivative of x, you do how? So you find the derivative of the external function. What's the derivative of the first function? F derivative of x. the f derivative of in the f derivative of x, there is some x, so in that x you insert the g. So f derivative of g of x, I'm sorry, f derivative of g of x is here, then times g derivative of x. This is pretty easy. Now find this one. What is, if f of x is what? If f of x is sine x squared, yeah? If this is the case, what is f derivative of x is equal to? So now what is, you have L of x is sine x, yes, sine x. What is the derivative of L? L derivative is cos x, yeah, the derivative of sine x is cos x. So what is the m of x? The inner one is x squared. What is m derivative of x? It is 2x. So how now? L or m derivative of x is equal to L derivative of m of x times the m derivative of x. This is very important. You need to know this. So how much is this? Where is L derivative? This is L derivative, but this is L derivative of x is cos x. But what is L derivative of m of x? So instead of this x, you are using m. So that is L times what? Instead of L, I'm using cos x squared times the derivative of x squared is 2x, yeah. So the derivative of d per dx of what? D per dx of sine x squared is equal to cos square x times 2x, or you can call it 2x cos x is the derivative. Okay, let's have another example. This is the second example. F of x is given as the square root of 1 minus 3x squared. Now, pause the video, try to split this root 1 minus 3x squared into two functions, okay? So, let's, then we will do, you will check your solution together with me. So, I can say there's one function, okay? Well, there's one function. That function may be L of x. The L of x is root x, simply root x. There is another function m of x. M of x is how much? 1 minus 3x squared, yeah. So I split this one into a composite function. That's a challenge, I know. But so what is L of m of x? Okay, meaning when you insert m of x in that x, you're gonna get square root of 1 minus 3x squared. Yes, so that is f of x. So meaning L or m is like f of x. All right. So how do we do this? So we are going to do the square root of x is one thing, then 1 minus 3x squared is another thing. So what is the derivative of this? D per dx of root x. We did this last time, I remember, but so I can write this root x as x to the power of 1 over 2, and I can treat this like a polynomial. So this is the same as 1 over 2 x to the power of 1 over 2 minus 1, yeah. So I can do this 1 over 2 times x to the power of what? 1 over 2 minus 2 over 2 instead of that 1. So I can do this 1 over 2 times x to the power of negative 1 over 2. Then this is how much? So this is the same as, what is 1 over 2 can be here. What is x to the power of minus 1 over 2? Okay, because it's of minus, you can take it 1 over 2 here. So you can just remember 1 over x to the power of 1 over 2 will be the positive exponent. This is the same as 1 over 2 times what? 1 over root x. Very simply, you can put this. The derivative of root x is how much? This derivative is 1 over 2 root x. All right, so this is the derivative of the first one. Let me rewrite the function again because of the space I have. So we have L is equal to root x, and the L derivative is equal to how much? 1 over 2 root x, yeah. Yeah, that's it. Then we have another function. So what is m is equal to 1 minus 3x squared? Yeah. So what is m derivative of x? This is equal to the derivative of this is 1 is 0 minus 3 times 2, then x to the power of 2 minus 1. So this is minus 6x. Yeah, minus 6x. Now how do you do this one? What is the d per dx of square root of 1 minus 3x squared is equal to how much? The first thing is you find the first derivative, then it is 1 over 2 roots. In the root, g of x is inserted, which is 1 minus 3x squared, then times what? Times the derivative of this one, minus 6x. Yeah, minus 6x. That's how it works. So this is equal to how much? Minus 6x over 2 roots 1 minus 3x squared. Yeah, so I can write the 6 squared. This is minus what? 2 times 3 is 6 times x is here. Then you have 2 times root 1 minus 3x squared. Yeah, you can eliminate this. So the d per dx of roots 1 minus 3x squared is the same as 3x over square root of 1 minus 3x squared. That's it. That's how you do the derivative. All right, this is a few examples for just a few examples, because it's a wide course. I can't complete it one these things within such smaller minutes. And thank you for watching. This is Mr. Fakada. Thank you for watching. Really አመሰግናለሁ guys. How are you?